Now, okay, the recording looks like it's starting. And I'm going to talk about inequalities. So I'd like to solve this problem. I can read my handwriting. So it's x cubed minus 8x squared minus 23x is greater than or equal to negative 30. So the thing I like to say about inequalities is they are just like equations. There's going to be a few other little steps, but if you can solve the underlying equation, chances are you can also figure out the inequality. And let me real fast, just kind of scratch work, kind of give you some reason for that. So since we're just talking about graphs, here's a graph with some function. So if I want to solve this as equal to 0, then I'm basically looking at when the y value is equal to 0, which are these points, which of course we call roots or solutions. So that'd be equal to 0. But if we want to change that to greater than or equal to 0, then these points, which are called critical points for the inequality, the solutions to the equality are still kind of guiding the inequality. And these are not the only solutions. These are still solutions. But we also get wherever the function is bigger than 0. So like this, we just kind of plop this down onto the x-axis. And this part, plop that down onto the x-axis. We get these solutions. I'm just going to make up some numbers here. So let's say it's negative 2 and 2, and say it's a 7. So all the points between negative 2 and 2 and anything bigger than 7, those are my solutions. Now that doesn't solve this problem. I'm just illustrating. So I'm actually going to erase that if you don't mind. But that kind of just as a quick illustration as to why solving the equation, oops, try that again. There we go. Is important. Okay, so let's solve this like an equation. The first step is to set it equal to 0. I'm just going to add this 30x to this to both sides. We get x cubed minus 8x squared plus. Oh, you know what? Should I goose this up? Yep. In case I'm not reading my own handwriting, this is supposed to be no x here. Sorry. If you don't mind, I'm just going to erase these x's. I didn't mean for that to those things to combine. Okay, so I'm just going to add 30 to both sides. So still have negative 23x plus 30. They're going to equal 0. Okay, so at this point we have a cubic or a degree 3 polynomial, and that's a pretty high degree. So we can't just use a quadratic formula or something. We have to factor it. I would try grouping to start with, but grouping, I can tell you, is not going to work on this one. So we're going to do the PQ method. Unfortunately, there's lots of possibilities for P over Q. So P over Q, well, Q is just 1, so that's nice. But 30 has lots of factors. So this could be 1, 2, 3, 5, 6. What else? 10, 15, or 30. I think that's all the possibilities. So when you have lots of possibilities, n plus or minus for all these, right? So when you have lots of possibilities, you're kind of going to cross your fingers and hope that one works. And in fact, in this case, it does. One is going to work here, I believe. So if you plug in just x equals 1, you're going to get 1 minus 8 is -7 minus 23 is -30 plus 30 is 0. So this leads to y is equal to 0. So that's going to work. That's the solution. Now at this point, of course, we want to do the long division. So let me go ahead and do a new page, and we're going to factor x minus 1 into our problem, which was x cubed minus 8, x squared minus 23x plus 30. And it should go in nice and evenly. So let me just run through this real quick. So x goes into x cubed x squared times x minus 1 is x cubed minus x squared. Draw a line, change the sign. We're going to get -7 x squared minus 23x. Bring this down. So x goes into -7x squared, -7x times. -7x times x minus 1 is -7x squared plus 7x. So we're going to draw a line and change the sign. We get -30x plus 30. Oh, that looks good. I like when those match. That's a good sign that this is going to be remainder 0. So if it goes to -30 times, we get plus 30. So we draw a line, change the sign, and we get a remainder of 0. Great. So if I go back to the original problem, well, actually, let me not go back to the original problem. Let's factor this over here. So we've now factored this thing as x minus 1 times our answer here on the top, x squared minus 7x minus 30. And this factors even more. So we get x minus 1, x minus, about this factor more. Oh yeah, x minus, we need two numbers that multiply -30 and add to -7. I think 10 and 3 work. So minus 10 and plus 3. Great. So if we were doing an equality problem, an equation problem, we would get x equals 1, x equals 10, and x equals -3 as the solutions to our problem. But we're not done yet for an inequality. For an inequality, we need to do a little bit more. And the easiest way to do this is, in my mind, is to just do a number line and test the intervals that work. So let me go ahead and do that. So I'm going to do a new page. So here was our original problem. So this was going to be bigger than or equal to -30. I'm just going to kind of take this kind of what we've already done is we've also kind of seen that this is equivalent to this. So if I just add the 30 to both sides, I already did that, and we already factored it too. So that's actually most of the work. X minus 1, x minus 10, x plus 3. So the way I like to do this, like I said, is to do a number line. So the three critical points that I have are from x minus 1, I have 1. So I'm going to mark well, actually, let me do an open circle to start with. We have x equals 1. We've got x equals 10. Maybe that's way over here somewhere. And x equals -3. All right, 10 is over here, -3 is over here. So For an inequality, these are not your solutions. They kind of, it lives between these solutions. And the easiest way to figure it out is just to say, is to test intervals. What do I mean by that? So I'm gonna pick points in these regions. So like over here, I could pick -4. 0 is always a good one to do. I always like 0, so we'll pick 0. We'll pick 2, and way over here, we'll pick, I guess 11. So I've just chosen whatever number I want in each of these regions of my number line. And then I just can go back to the original inequality, or for polynomials, you don't have to go back to the original. You can actually go to this one as well, and you just plug these in and see if they satisfy the inequality. If they do, then that whole interval works. And if they don't work, then that whole interval does not work. So kind of the first thing maybe well, let's just try 0. 0 is always the easiest to try. So if I try 0, let me try it in the original first. So if I try 0 in my original, I'm just going to basically plug in a 0 for all of these. And then I just ask myself, so if I plug in 0, what does that end up saying? Well, that says that 0 is bigger than or equal to -30. Is that true? Yeah, that is true. So this is actually a good point. So what that means is I can shade this whole region as, yes, that's a good solution. What I think is easier, I mean, there's nothing wrong to plug 0 into any of these, but what I think is actually easier is to use this equation, because if I plug in 0 here, all you really care about is whether these are positive or negative. So if I plug in 0 here, so that's going to give me, this is going to be negative, positive if I plug in 0, because I know like 0 minus 1 is negative. I know 0 minus 10 is negative. I know 0 plus 3 is positive. So I can just quickly see if these are negative or positive, and then I know a negative times a positive is negative times negative is positive times positive is positive, so I know this is going to be bigger than or equal to 0. So doing that method with these other ones, like -4, I know this is going to be negative times negative. That's not going to work if you're following along with me. And there's nothing wrong with just plugging in -4 into this one up here and seeing if that works, but that takes a little bit more thought or calculator pushing at least. Whereas this positive negative stuff is really easy, like 2. Well, this is going to be positive, negative, positive for 2. Positive, negative, positive, that's negative again, that's not going to work. And 11, well, 11 is big enough, they're all going to be positive, so it's definitely going to work and be bigger than 0. So I'm going to shade in this part of the region as well, because 11 works. And so that's basically my answer, except I also have to determine if I want to fill in these circles. And that's basically just, is this a strict inequality, or is this just greater than, or is it greater than or equal to? Since this is greater than or equal to, we do shade these in. So a shaded in dot is basically corresponds to less than or equal to, greater than or equal to. An open circle corresponds to one of these stricter inequalities. So in this case, we want to shade those in. Okay, I am going to stop the video now.